Great to see you here again. My name is Luc de Koster, founder of the Koster Academy, and I'm presenting a new video from our Math Survival Guide. But before we start, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. So what we're going to do here, we're looking at quadratic polynomials, and we're going to use the method of trial and error to factorize the equation. It's a very interesting way to find the factorized form. There are different ways to factoring equations, but now we're looking at this trial and error method. So basically, when we are factoring quadratic equations, we use the method of trial and error. And what we are doing basically, when we have a quadratic equation of the form ax squared plus bx plus c, we're trying to write this expression as a product of two first-degree polynomials, px plus r times qx plus s. So basically, whenever we're trying to factorize, we try to rewrite polynomials as a product of first-degree polynomials. And the ideal case is that we have a product of only first-degree polynomials. In some cases, we may not find all those first-degree polynomials. We may have a combination of polynomials of different degrees. So basically, when we look at this, we try to find an expression px plus r times qx plus s, and basically we want to find those parameters p, q, r, and s, which are the coefficients of those first-degree polynomials. So we try to find those values, p, q, r, and s, and let's see how we do that. Let's first have a look at how we develop the formulas a little bit more in a theoretical way. So the principle is in fact that we have ax to the square plus bx plus c to be written as a product of two first-degree polynomials. Now, when we do the multiplication, when we expand the factorized form, so we first multiply px with qx, we're using the distributive property. Then we multiply r with qx. Then we multiply px with s and r with s. So basically we find the first expansion, which is px times qx plus rqx plus pxs plus rs. And now we are going to group this with the different factors, the coefficients of x to the square, x, and the x to the power 0. So basically we can rewrite this as pq x to the square plus rq plus ps times x plus r times s. And we know that p times q is equal to a, rq plus ps is equal to b, and rs is equal to c. So basically what we can say when we summarize this, we can say that we have a set of equations where pq is equal to a, rq plus ps is equal to b, and rs is equal to c. And we have to find in different ways the values of p, q, r, and s. So that's in fact the principle. Let's have a look at a simple example. We have an expression here, x to the square plus 7x plus 12, which is the function of x, f of x. And we want to write this, in this case, when we take the equations that we developed before, we can say that p times q is equal to 1, p times s plus qr is 7, and rs is 12. Based on the fact that p times q is equal to 1, it also results in the fact that p is equal to q is equal to 1. Then we can simplify the expressions because we can replace p and q in ps plus qr, and we find s plus r is equal to 7, and rs is 12. So this is also called the sum and the product formula. In other languages, you may have a specific name for this. So what we have to do now, we have to solve this. So we have s plus r equal to 7 and s times r is equal to 12. What are the possibilities to have two integers to have a sum s plus r equal to 7? So we have 1 and 6, 2 and 5, and 3 and 4. Then for 12, what are the two integers that give a product equal to 12? Well, we have 1 and 12, 2 and 6, 3 and 4. And we see that we have one combination here, 3 and 4, which gives us a sum equal to 7 and a product equal to 12. So basically this means these are the solutions of S and R. Now, based on this, we can say that x to the square plus 7x plus 12 could be equal to x plus 3 times x plus 4. We put a question mark there because we now have to verify if this is really true by expanding the product x plus 3 times x plus 4. So when we look at this, we multiply x with x, which gives us x to the square, 4 times x, 3 times x, and 3 times 4, which is equal to 12. And when we now add everything together, we see that we find x to the square plus 7x plus 12, which is what we had to prove or quid et demonstrandum. So QED means that we have proven that those two are equal. Now let's have a look at another example here, and we find x to the square plus 8x plus 15. We can again use the same formulas. S plus R is in this case equal to 8, and S times R is 15. So we find the different possibilities for S plus R to be equal to 8. We have 1 and 7, 2 and 6, 3 and 5, and 4 and 4. And for S times R, we have two possibilities, 1 and 15, and 3 and 5. So again, we see that we have those two combinations in common, and we can say that x plus 3 times x plus 5 can be equal to the result. So we do the expansion, x to the square, 5x, 3x, and 15. And we find the result here, x to the square plus 8x plus 15, and it's equal to the original equation. It's always important to do a check to be sure that you didn't make any errors. So that was it. We had some calculation here, how to use the trial and error method. Let's have a look at some other examples in some other videos. Anyway, don't forget to click the subscribe button. Don't forget to click the bell button. And of course, I'm looking forward to seeing you in our next video. Thank you very much and bye-bye.